Review 5, Charge and Current. By definition, current is an amount of charge passing a fixed point in a given amount of time. Write the equation expressing this definition. Current is the amount of charge per time. Modify the right side of the Part A answer for the case where a very tiny amount of charge passes a fixed point in a very tiny amount of time. The current at any particular instant is the tiny amount of charge that passes a fixed point in whatever tiny amount of time has elapsed. Suppose the amount of charge passing a fixed point as a function of time conforms to that equation right there. What have to be the units on these various constants? Let's start with an easy one. This gamma constant, charge is in coulombs, and gamma is just by itself, so that's got to be coulombs. On the other hand, this quantity right here, beta times t, that has to have the unit coulombs, and the time is in seconds. Beta must have the unit coulombs per second. And this one that I've circled, okay, I'll circle all of them. Circle this one. The alpha must have what unit for that thing to have the unit coulombs? Well, alpha must be coulombs per second squared, because when you multiply coulombs per second squared times seconds squared, which clearly is what t squared is going to be, that'll give you coulombs. So I think we're good there. All right, based on the equation, write the equation that shows how the current would vary with time. That means that we're going to find the time derivative. So that's going to be 2 alpha times t plus beta. Suppose now that a current varies with time according to this function here. Write the equation for the amount of charge that has passed a fixed point during the time interval from t equals 0 to t equals t. If we know the equation for the current per time and we want to know an amount of charge that has passed, then basically what we have to do to find the charge, don't we have to go, okay, from time equals 0 to time equals t, because those are the limits that are given here, we would need to integrate this with respect to time. Can we do that? Let's try. Integrate that, so I'm thinking that that's going to be 1/3 sigma t cubed plus 1/2 pi t squared plus theta. Now, should we put a time constant on there? Adding a constant. Well, we are doing these limits, aren't we? From t equals 0 to t equals t. And we've said anytime you have a definite integral, you don't have to worry about the c. So I think, oops, I forgot to multiply theta by time here. Oops. There we go. Put that in there, right? Because when you integrate theta with respect to time, you get theta times t. I think all of this is good. Let me just rewrite that. I got 1/3 sigma t cubed plus 1/2 pi t squared plus theta times t. That's the total amount of charge that passes a fixed point between time 0 and time equals t.